Yes, good day everyone, and welcome to our presentation for today, or lesson of today. Um, we're going to look at certain things in our lesson, in this lesson. Firstly, we're going to look at what is synchronous transmission, and then we'll look at asynchronous transmission. We'll look at telecommunication channel characteristics. We'll look at multiplexers and demultiplexers. So this is the layout of our presentation for today. Okay, so let's just move on to the next slide. So basically this slide is showing us the basic telecommunication process or system, like what happens when two devices are communicating. Okay, so you've got a sender here, okay, from this side, and you have got the receiver. So this PC, this node is sending and this one is receiving. So we call it, this one is a sender and this one is a receiver. Okay, then for this communication to happen, there must be a link in between. Okay, so in this case, we have got a cable. Remember, we talked about this in the first lesson, in the other lesson on transmission media, data transmission media. So this one is a cable that connects these two PCs. Okay, so you can also have it wireless. Okay, you can connect it wirelessly. Okay. And then for these, whatever exchange of data between these two PCs, you also need a protocol. Okay, we say the protocol is a set of rules that govern the communication between the two. Okay, so if this is a client and this is a server, like a web server, so the protocol that needs to be used here is HTTP. Okay, so you also need a protocol here. So we need a protocol to send between these two devices. Okay, so this is just a simple communication setup or process. Okay, so let's look at the next slide, which is talking about the synchronous transmission. So what is synchronous transmission? We say the synchronous and data transmission is transmission. It's a data transfer method in which a continuous stream of data signals is accompanied by timing signals generated by an electric clock to ensure that the transmitter and the receiver are in step or synchronized with one another. Okay, so basically we're saying it's a method of data transfer that happens between two devices, whereby a continuous stream of data is accompanied by timing signals. Okay, so whatever you are transmitting is accompanied by a timing signals. Okay, and this signal is generated by electronic clock, and the purpose of this is to ensure that the transmitter and the receiver are in step with one another. Okay, like they are in a mode of receiving, of sending data. Okay, so they're kind of synchronized. Okay, so the two are synchronized. The data is sent in blocks called frames of packets, and they're spaced by fixed time intervals. So these data are sent in blocks. Okay, and most of them are spaced by a fixed time interval. So in between these blocks, there are time intervals. Okay, and then synchronous transmission. They are used when large amounts of data must be transferred quickly from one location to another. We're saying it's large amounts of data must be transferred very quickly from one location to another. So basically, what we are saying here is you have got a source and the def and the receiver, which is not the destination where this data is being transferred to. Okay, so and then in between here you are having these two devices that are connected together, and they have to transfer large amounts of data. So that transmission, whereby large amounts of data, it's transferred in a quick way from one location to another. Whatever happens there, or that certain transmission that happens or that takes place there, it's what you call a synchronous transmission. The data blocks are grouped, as you can see here. The data blocks is grouped and spaced in a regular intervals. Okay, so this is the blocks. You talked about large block of data. So this is a block of data. Okay, then so what you're saying here is the data blocks are grouped and spaced in regular intervals. Okay, so this is blocks of data. Okay, as you can see here, these are blocks of data, and they are spaced in regular intervals. Okay, regular intervals say okay, so we've got this block here, and then we've got this block, we have got this block. So all these are spaced in a regular interval. Okay, meaning if this block should go first, and then once it reaches the destination, then the other one follows. Okay, like there's a sort of a regular intervals in between these blocks. Okay, and they are preceded by special characters called syn or synchronous idle characters, as you can see here. Okay, these are syn. These are special characters that we are talking about. Okay, and these characters are actually for to tell the systems or alert the system that a certain data was sent or it's about to send. So so you have to start sending and stop sending. Okay, so this is what basically these two characters here are for. Okay, moving on to asynchronous system or transmission. In contrast, asynchronous transmission works in spurts and must insert a start bit in each data character and a stop bit at its termination to inform the receiver where it begins and where it ends. Okay, so as you can see here in this block of information or data here. Okay, so in this transmission, there must be a bit that should be inserted so that it alerts the system. The system should be alerted that I'm about to send the data or I'm about to send a bit. Okay, so you should have a start bit and a stop bit. Okay, so when you're sending an info data, you need to alert the systems that you are about to send us something data. Okay, and then when you are done, or when you want to terminate the transmission, then there must be another bit that have to be sent for the other side to know that this transmission has ended. Okay, so you need to have a stop bit and the end bit. Okay. The term asynchronous is used to describe the process where transmitted data is encoded with a start and stop bits, specifying the beginning and the end of each character. Okay. So you have got the start bit and the stop bit. Okay. So each of these characters is preceded by a start bit. Then when it stops, it should have, or when it's done, if it's received, then there must be a bit that is also transmitted from the center to the receiver, from the destination receiver to the transmitter, just to alert the receiver, the transmitter, that a certain one character or sample has been received. Okay. These additional bits provide the timing or synchronization for the connection by indicating when a complete character has been sent or received. Okay. That's timing for each character start bit and ends with the stop bit. Okay. So basically, what you're saying here is when you're sending a bit, characters or data, first as start bit is sent to alert the other side of the connection or the of the transmission that node A is about to send a packet, I mean a data packet. Right? So when this transmission is done, then another bit has to be sent, like a stop bit that says, no, this is the end of the transmission. Okay. All right. Moving on to the next slide. We'll have basic telecommunication characteristics. So we're going to look at the half duplex channel and the full duplex channel. So what is the difference between these two? With half duplex the channel, the data transmits, with this channel, it transmits data in either direction, but not simultaneously. Okay, so basically it transmits what? Data in either direction, but not simultaneously. So it's only one, it happens once. Okay, so it's one way, but you can transmit it in any direction. Okay. So an example of half duplex will be a walkie-talkie as a good example of half duplex channel, whereby walkie-talkie, where you push the button, and then this button used to turn on the transmitter button of the receiver. Okay, so when you turn on the walkie-talkie, it turns on the transmitter, but it turns off the receiver, because these two the two cannot talk at the same time. Okay, this should not, the transmission should not happen like so one side should listen, but the other one have to send or transmit. As we have already said here, that it transmitted in any direction, but not simultaneously. Okay, when the button is pressed, the transmitter cannot hear the receiver, but receiver can hear the transmitter. Okay, so this is more on that's how a full duplex actually works. Moving on to the full duplex channel. So with this one, we permit data transmission in both directions at the same time. Okay, so it's unlike half duplex where it's only in one direction, in either direction, but not simultaneously. So this one, it's a two-way traffic. Okay, so the transmission can be from both directions at the same time as well. Okay. So with a full duplex, it's composed of two or more connected parties or devices that can communicate with one another in both directions. Okay. So you've got two parties, and then they do communicate with one another in one direction, in both directions. Okay, I say it, and then you listen, then you respond to what I've said. Okay, duplex systems are employed in many communication networks, either to allow for simultaneous communication in both directions between two connected parties, or to provide a best path for the monitoring and remote adjustments of equipment. Okay, so these are the different duplex channels that telecommunication uses. Okay. All right, moving on, we have got what you call multiplexers and demultiplexers. Demultiplexers. The multiplexers, they are devices that allow several telecommunication signals to be transmitted over a single communication medium at the same time. Okay, so you have got a number of devices, and they are communicating to the other side. So all these devices their signals have to share the same medium, the single communication medium, and at the same time as well. So they are blended together, then they become one. They share the medium actually. Okay, all right. So these are devices that allow several telecommunication signals to be transmitted over a single communication medium at the same time. Okay, so all these signals are transmitted at the same time using this a single medium of transmission. Okay, whereas the demultiplexers is the opposite. Devices that allow multiple analogs signal to combine. Okay, now the so with the demultiplexers, say when okay, now let's look at this example here, this illustration. So we are having this picture here. So this is a source where the information is coming from, and it's going this side, or it's being transmitted this side. Okay, so these are the different devices that are transmitting data. So we got 10, 20, and 30. All right. Now with the multiplexer, it combines all the signal from all these three devices, and then they share the medium. They use one medium instead of them each of them sending like separately. Okay. So this saves time and resources as well in the system. Okay. So the signals are combined and then they share a single medium to its destination. Okay. So that's multiplexers. Now with the demultiplexer device, what it does is, so once this information or these signals reaches the destination, then they are demultiplexed, okay? Like they are separated, and then each of them goes to each and every device where it was intended to, okay? So if 10 was sending to 20, then it's assigned, or it goes to 20. So 20 was sending to 10, and so and so and so, and 30 to 30, and so and so and so. Okay. So here they are being demultiplexed. Okay. So there's a device, as we are saying, multiplexer is a device. Here it combines the signal, but here it separates them to their respective destination. Okay. So as you can see here, they are all sharing the same medium here. Okay. Right, so that is the end of our lesson. It was so short, and so if you guys have got any question, please, you are free to ask me. For now, see you.